and welcome to the next edition of Learning from Home with Mrs. Beckett. Today we're going to take a look at area and perimeter. Area and perimeter is probably something that you've done in elementary school. So for some of you, you might find this as a simple review. Others may have not been exposed to it as much in elementary school, so you may feel like this is a new challenge to take on. Either way, we're going to walk through some examples, we're going to talk about some definitions, and I'm going to give you some time to practice those questions today before you do a Knowledge Hook quiz. So an introduction to perimeter. So it's important to remember that perimeter is the distance around a closed shape. The perimeter of any shape can be found by tracing your way around the outside of the figure edges, adding up each side length until you return to the starting position. So when we're calculating the perimeter of any sort of shape, whether it's a regular shape, a composite shape, or an irregular shape, we just want to take a look at the outside edges. So if I was looking at calculating the perimeter of this triangle here, I would simply just add up 10, 8, and 5, because those are my outside edges. So 10 plus 8 plus 5. And I can either do this using my mental math or I could use a calculator if I need to. So 10 plus 8 is 18. And 18 plus 5 is 23. And I always want to take a look at what my units are. So right now this is being measured in inches, so I want to include my inches in my final answer in order to get full marks. Let's take a look at part B. So part B again, I want to take a look at my shape and I want to look at all of my outside edges. So I'm going to add up my 1, my 2, my 4, and my 3.5. So perimeter is 1 plus 2 plus 4 plus 3.5. 1 plus 2 is 3. 3 plus 4 is 7. And 7 plus 3.5 is 10.5. Now you could have done that quicker in a calculator or by combining some of these steps, but I just wanted to walk you through those. And I always include your units, which is kilometers. If we were in school, I would have you measure this arrow for part C, but we're not in school, so we're going to skip this question. We would talk about how we can measure the difference between measuring something in centimeters, millimeters, or inches, and how we can convert between the two of those as well. All right, so let's move on to the questions on the back. So the shapes that are displayed on this side of the page are different from the first 3 examples on the front of the page because these are what we call regular shapes. So these are shapes that we want to take a look at. And when we're talking about regular shapes, we're talking about those basic shapes that we know that we can have a formula for. So in Brightspace, there is a Equio formula sheet. Equio is our grade 9 math assessment, and they provide you with a formula sheet for area, perimeter, volume, and surface area. And so it's important to maybe print that out if you have access to a printer at home, because you're going to be referring to it in the next few lessons. So we can just simply add up all of the sides. So we notice that they have each side of this square has a little line through it. So this means that all of my sides are the same measurement. So I could add up all of these sides, so 7 plus 7 plus 7 plus 7, and figure out the perimeter that way. Or because this is a square, I could use the perimeter formula for a square. Because all of my sides are the same and a square has 4 sides, I can do 4 times 7, which gives me 28, and my units are meters. So either way would give you the same answer. So just whatever method works best for you. You might find that using the formulas could be more efficient in the long run. Part E, we have an equilateral triangle. Again, all of these sides with the lines through them show that they are the same measurement. An equilateral triangle has 3 sides that are all the same. So again, I could either add up each of those sides, or I could use a formula. Because all of my sides are the same, the perimeter could be 3 times s, or 3 times 8, which will give me 24, and my units are centimeters. For part F, I have a rectangle. For a rectangle, the sides across from each other have the same measurement. So I could either add up all of my sides by going around the outside of my rectangle, or I could use the perimeter formula for the rectangle, which is 2 times length plus W, or 2 times 24 plus 8. Follow BEDMAS, so 24 plus 8 is 32, and 32 times 32 times 2 is 64. Always include your units. In this case, it's millimeters. Part G is a parallelogram. So parallelograms are similar to a rectangle in that the sides across from each other have the same measurement. You'll notice I use 1 line and then 2 lines because these are different side lengths. I don't want to use just a 1 line here as well. I want to show that all of my sides are different from the ones that are across from each other. So the perimeter of a parallelogram, again, I can just add up my sides together. 4.3 plus 3.8 plus 4.3 plus 3.8. Or I could use my formula. So the formula is, I'm going to use another version of my rectangle formula, which is 2L plus 2W. So 2 lengths times 2 widths. So you could either use the formula from the rectangle, or you could use this formula as well. So 2 times my length, so 2 times 4.3, plus 2 times my width, 3.8. It doesn't matter whether you put the 3.8 in for your length or your 4.3 in for your width. And then because this is decimal numbers, you may want to use a calculator, but you don't have to. So 2 times 4.3 will give you 8.6. And 2 times 3.8 gives you 7.6. And when I add those two together, I get 16.2, and my units are meters. And the last shape that we have, again, all of my side lengths are the same, and I have 1, 2, 3, 4, 5, 6, 7, 8 sides, so this is an octagon. I could either add up all of my sides 8 times, so 1.5 plus 1.5 plus 1.5 plus 1.5 plus 1.5 plus 1.5, 1, 2, 3, 4, 5, 6, 2 more. Or because all of my side lengths are the same and I have 8 sides in an octagon, I can do 8 times S, where S is the side length, so 8 times 1.5. And 8 times 1.5 gives me 12. Include your units, which is meters. All right, so let's take a little break, answer some questions. So from your Check Your Understanding worksheet, take a look at part A. Do question number 1, do part A, B, and then choose between C or F, and then D or E, and then 3B. Work productively on these questions, ask for help if needed. So, chat me up on Teams using audio, video, or the chat feature. Ask for help if you need it. Check your answers on Brightspace. They're going to be posted there so you can make sure you're on the right track. And when you're ready, you can restart this video and take a look at the next section of this lesson. All right, welcome back. So, still looking at perimeter. So remember that perimeter is the total distance around a shape. Now, when we have composite figures are shapes made up of combining 2 or more simple geometric shapes. For example, if we have something that looks like a house, it's the combination of a triangle and a rectangle. So we are adding the triangle roof to the rectangle bottom. So it's important to think about when we're looking at composite shapes to only include the outside shapes, not any of the inside shapes. So when we're counting the number of outer edges for shape A, we have 1, 2, 3, 4, 5. For shape B, we have 1, 2, 3. And for shape C, we have 1, 2, 3, 4. But 3 plus 4 gives you 7. But we only have 5 shapes or 5 sides for shape A. And why is that? Well, because the triangle and the rectangle share the one edge. So side 3 for the triangle is the same as side 1 in the rectangle. But those are also going to be interior sides. So they actually don't fall on the outside of that perimeter. So that's why shape A is not going to have the same number of outside edges as the 2 individual shapes added together. So to calculate the perimeter of a composite shape, add the edges on the outside of the figure only. Sometimes the outer edges are not given and must be calculated first. So make sure you know all of the outer edges before finding the perimeter of that shape. So when they're a composite shape, we still want to follow those same rules. So we want to add up all of the outside edges. So we have 1, 2, 3, 4, 5, 6 outside edges. So we must have a measurement for all 6 of those sides. We have it for 1, 2, 3, 4, but we don't have it for 5 or 6. So we're going to calculate the side 6 first. We know that this top edge here is 5, and this top edge here is 5, and those make up the entire width of that rectangle. So this is going to be 5 plus 5, which is 10 meters. So that's the measurement for side 6. So now let's take a look at side 5. So we know that the entire length of this, or the height of this shape, is 11. We know that this little section right here is 2. So if I subtract 2 from 11, I should get the leftover side for 5, which would give me 9 meters. So sometimes you might have to do some preliminary calculations just before you get started. So now that we've done that, now we can calculate the perimeter of this shape. So the perimeter is 11 plus 5 plus 2 plus 5 plus 9 plus 10. And you can either use mental math for this, or you can type this into your calculator. 11 plus 5 plus 2 plus 5 plus 9 plus 10 gives us 42, and my units are meters. Taking a look at the next example, again, I want to look at all of my outside edges here. So I have to think about, what do I know already? Well, I know this is 7. I know that this is 6. I know that this side is 3, but this little symbol here shows me that all of these other ones with the one single line through it is also 3. So this is 3 centimeters, and this is 3 centimeters. I know that this is 5 centimeters, but it has 2 lines through it. So I know that this top other side of here is also 5 centimeters. And so now it's just a matter of finding this length right here. Now this one's a little bit tricky, okay? So we need to think about, what is this measurement right here? Well, I know that from here to here is 3 centimeters. Because that's the same as this section right here. And I know that the entire height of this is 7, and I don't need to go up 7. So from here to here is 3 centimeters. And so I just need to look at, what is this little part right here? Well, this little part right here will be 1 centimeter. And I can do that using my calculations, because I know that this will also be 3 centimeters, and like this top part here. So this is what's missing up here. And 3 plus 3 plus 3 is 9, plus 1 is 10, which is the same as 7 plus 3 here. So now we just need to add up all of the sides. So I'm going to start with my left-hand side. So 3 plus 7 plus 5 plus 6 plus 3 plus 3 plus 5 plus this entire length right here is 7. So plus 7 plus 15. And then just take a look at adding that up, either using mental math skills or by putting it into your calculator. And you get an answer of 54, and my units are centimeters. So now I want you to do some more questions. So pause this video, work productively on the questions that are assigned to you. So take a look at part B, 4 and 5. Just do the perimeter. So it asks you to calculate the area and the perimeter, but just do the perimeter right now. Okay, so work productively, ask for help if you need to on Teams, and check your answers on Brightspace to know that you are doing them correctly. And when you are ready, you can restart this video and we'll take a look at the next part of this lesson. All right, welcome back. So now we're going to take a look at perimeter of figures with circles. So the perimeter of figures with circles. So the perimeter of a circle is called the circumference. So this entire edge of my circle on the outside is my circumference. That's right here. The diameter of a circle is the entire width of my circle. So this is the diameter, and the radius of my circle is half of the diameter, or half the width of the circle. So the circumference of a circle can be easily found if you know either the diameter or the radius. So you need to know at least one of those. So either the entire width of the circle or half of the width of the circle. And there are two formulas that we can use. So either C equals pi d or C equals 2 pi r. So they're really the same formula since the radius is half of the diameter. So whatever the measurement you have will just dictate what formula you want to use. Remember that if you don't have a pi button on your calculator, you can use the value of a pi, which is approximately 3.14. Now, pi is an irrational number. It goes on forever and ever and ever, and it never ends. But make our calculation simple, we'll just use 3.14. Or if you have a pi button on your calculator, it'll put in as many decimal places as your calculator will hold. So let's take a look at some examples. For example A, I know the radius of my circle, halfway, is 12 centimeters. So I'm going to use the circumference formula that includes my radius, which is 2 pi r. So I'm going to do 2 times 3.14 times my radius, which is 12. And I'm going to multiply all three of these numbers together. 2 times 3.14 times 12 give me an answer of 75.36 centimeters. But sometimes I like to round up my answers to the nearest tenth, so that's 1 decimal place. So 75.4 would be the answer rounded up to that 1 decimal place. For part B, I know the diameter of my circle, so I'm going to use my formula that includes the diameter, which is pi d. So pi is 3.14, the diameter is 9. I'm going to go ahead and multiply those two numbers together to give me an answer of 28.26 kilometers this time. And if I wanted to round it to 1 decimal place, it would be 28.3 kilometers. Sometimes you're going to have just parts of circles, so it's important to think about that as well. So when we are involving parts of a circle, we want to think about how many curved edges I have and how many straight edges I have. So the number of straight edges I have is 1. The number of curved edges I have is 1. So when I'm looking at the perimeter of my shape here, I want to add both my curved edges and my straight edges together. So my straight edge is 11, but my curved edge is half of a circle. This is a semicircle. So I'm going to take my formula for the circle, so pi d, because I know the diameter, and I'm going to divide it by 2. So I'm going to take 3.14 times 11 divided by 2. And I can do this all in my calculator. So 3.14 times 11 equals 34.54, and divide that by 2 gives me an answer of 17.3 if I round up to 1 decimal place. So now when I want to figure out the total distance of this shape, my total perimeter will be the length of my straight edge, which is 11, plus the length of my curved edge, which is 17.3, and that gives me an answer of 28.3 kilometers. Sometimes you might have a composite shape that includes part of a circle and another shape. So if I was to divide this shape up into shapes that I know that this is a semicircle up here and a rectangle at the bottom. So I have 1, 2, 3 straight edges, where these 2 on the sides are going to be the same length, and I have 1 curved edge. I already know how to calculate the circumference of a semicircle from my first example right there. So pi d over 2. This 20 centimeters is the same as my diameter. So I'm doing 3.14 times 20 divided by 2. So go ahead and plug that in. 3.14 times 20 divided by 2 gives me 31.4, and my units are centimeters. So now when I'm looking at the total perimeter of this shape, I'm going to add up my 25 plus 20 plus 25 plus 31.4. Which gives me an answer of 101.4, and my units are centimeters. And the next one includes 3/4 of a circle. I know that this 8 meters right here is the same as my radius. So I have two straight edges, and I have one curved edge. Because I am only having 3/4 of a circle, when I'm looking at the perimeter of or the circumference of my circle, I want to take my 2 pi r and I want to multiply it by 3/4. So you can think about this as one giant fraction. So the circumference is 3 times 2 times 3.14 times my radius, which is 8, all divided by 4. So follow BEDMAS. So do all my multiplication on the numerator first. So 3 times 2 times 3.14 times 8, that gives you 150.72. Divide that by 4, gives you 37.7 when I round to one decimal place, and my units are meters. Now, because this is the radius and this is also a radius, I know that both of these lengths are 8 up here for those straight edges. So when I'm calculating the total perimeter of this shape, it's going to be 37.7 plus 8 plus 8. And that gives me a value of 53.7, and my units are meters. All right, it's time to practice some of those questions. So part B, you're going to take a look at question 10, just the perimeter only. And then for part C, take a look at 11A, the perimeter only, and check the answers on Brightspace to make sure you're doing them correctly, and ask for help if you need to on Teams.